Hey everyone, welcome to another simple science video. And in this video, we are going to be looking at brittle materials and how they behave under stress when they are basically extended. So, in our previous video, we looked at some wires extending. We looked at how they behaved under stress. We looked at some values such as the ultimate tensile stress, a value where if you exceed it with a certain force, the wire will break. Okay. But this time, brittle materials, their behavior is different from our metal wires, but they are much simpler to understand. Okay, so brittle materials are basically materials that are considered to be non-malleable or ductile. Okay, so it's unflexible, but to an extent, it is flexible. But we are going to look at how insignificant it is. So some example of our brittle materials are glass or metal alloys, are basically metallic structures with little impurities that will cause it to disrupt this layered structure. All right, or any other amorphous material. So you're looking at the glass, okay, and metal alloys such as cast iron would be an example of a brittle material if the percentage of carbon in it is quite high. So an amorphous material is a material where the interatomic structure is undefined. It's not necessarily undefined, but it's very unorganized and it doesn't follow a particular pattern, such as in ice there's hydrogen bonding, but in an amorphous material there isn't any particular structure. Okay, and when you look at trying to stretch some brittle materials, you would find out that through a certain small extension, you try to flex this thing, you try to flex this glass, it will break. Okay, it will not withstand very small, quite small extensions before it will break. And it will be even harder to try to extend lengthwise a brittle material, such as this, say, strand of glass. Well, it can extend, but it would extend in insignificant amounts before it will start to break. And although this happens, you will require a very, very large force in order to cause quite small extensions. So therefore, it would have a very large elastic constant. And that is assuming that it's behaving under a linear behavior. So after very, very small extensions, they will actually break. So when we look at this graphically, we will find out that at the start, they will follow a linear force and extension relationship. See, there's a constant gradient, and it only happens for small extensions before the limit of proportionality and the elastic limit is reached. Okay, but basically, immediately after the limit of proportionality or the elastic limit, you would enter the small plastic region of this brittle material. It's so small that it's insignificant in that the plastic region is basically a region beyond the elastic limit where there is still a positive gradient on the graph. But if you can look at this brittle material behavior graph, there is virtually no plastic region where there's a positive gradient after the elastic limit. Alright, so immediately after you've left the elastic region, you would basically cause it to break. It will reach its breaking point. Okay, so to quickly summarize this video, brittle materials are materials that are considered to be non-malleable or non-ductile. Okay, and they are very, very large elastic constants. You see how great the gradient of the graph is. You have to apply a huge amount of force to cause it to undergo small extensions, and it will have a small plastic region where there's basically a positive gradient beyond the elastic limit. Okay, thank you for watching my video. Please come back and watch my previous videos on work, energy, and power to make sure you haven't missed anything in your study or your revision. And other than that, have a nice day, everyone.